Hi, everyone. Welcome to the Cloud Track, and my name is Alina, as Valia introduced me, and I'm happy to be a host here for the whole day, and I'm happy to be here together with my co-host, Sergei. Hi, Sergei.
Hi.
Yeah, let me introduce our speaker to you, Sergii Bishyr, and he will be the first to open our cloud track. Sergei is a software engineer at Logica, and he's also an active open source contributor. He has more than 6 years of experience of building distributed systems in different domains. For example, such as healthcare, alarming system, networking, debugging applications, and many more complex systems. And I let Sergei to introduce his talk and to start, and enjoy the talk, and let's start.
Hello, everyone. So first of all, let me share my screen. Okay, so today we're going to be talking about fault-tolerant applications, what it is, and how to achieve fault tolerance using such tools as Kubernetes and Istio. So my name is Sergei. I'm working at Logica in Ukraine, Lviv. So you can see my Twitter handler. In case if you have some questions after that, you can always message me. My DMs are open. Okay, so let's begin with the talk. Let's start with the fault tolerance, but I want to tell you one story, interesting story about Mars Climate Orbiter. This was a space program launched by NASA. It was launched in December 1998, and it arrived to Mars in 1999, 1 year after it was launched. And it was supposed to enter the orbit of Mars at the distance of 226 kilometers from the surface of Mars. But unfortunately, it entered into the Mars atmosphere at the distance of 57 kilometers from the surface of Mars. And it burned up into the atmosphere of Mars, which it wasn't. And what was the problem with this space program? It turns out that the problem was quite simple and quite stupid. One team was units such as inches, foot, miles, and other team was using the Stardust metric system, which we are using, for example. And this was the problem, which causes this catastrophe, the failure. So before we are starting talking about fault tolerance, I think we should start talking about such terms as fault, errors, and failures to understand what it is and what the failure is. So first of all, this is the fault. Fault is some defect in the system, the bug in the system. It may not appear yet, it's just there. So for example, in case of Mars Climate Orbiter, using of different systems is a fault. Fault can cause the error. Error is some incorrect system behavior. The system might continue work, but it's something that user may notice. So in case of Mars Climate Orbiter, entering the atmosphere of Mars was a clear error, which led to failure. Failure is a broken system when nothing works. So what does fault tolerance mean? Does it mean that our system should not have any fault, any error, and with this, any failures? The answer is no. So to explain this, I will tell you one more story about the Mars Exploration Rover program. You might heard about the Spirit and Opportunity rovers, which was exploring the surface of Mars. These two programs was launched in 2003. It was planned for 19 sols. Sol is a day on Mars. It's slightly longer than the day on Earth. Lasted for more than 2,000 sols on Mars, which is more than about 5.5 years. And Opportunity officially ended about 1 year ago, and it lasted for 15 years. Does it mean that all of these 15 years, there was no errors, no faults with these rovers? Of course not. First of all, the construction of this rover was that one of the wheels of the rovers stopped working, and the engineers had to move these rovers backward. One of the exploration tools was broken, but still, even with this fault, the rovers could last for so long, much longer than it was planned initially. So this is the idea of fault tolerance, that the faults, there will be in the system anyway. In every application, in every system, I can guarantee that there will be faults. But it shouldn't break the system. Your user should be able to continue using it. So today I will be explaining how to achieve some fault tolerance using Kubernetes and Istio tools. This is not the talk about the Kubernetes and Istio specifically. So if you're not aware with these tools, that's completely okay. I'm not going to go deep into it. There are plenty of talks in the internet about this, including some of my talks, but I will briefly go to these tools. So first of all, Kubernetes, this is a cluster orchestration, which allows you using Kubernetes control plane to distribute your application across different nodes to control that it's running and it's okay in the state that you want. And Istio introduced another level of abstraction by introducing some specific proxy near each of your application. And with this proxy, you can do a lot of different things. We will see it in the future. Okay, so for now, let's explore Mars. What do we need for the Mars exploration? First of all, of course, we need the rover to go through Mars and explore it. The rover cannot be autonomous, so it has to talk to some ground control, for example, to receive its name and to receive some coordinates of other rovers and send its own coordinates to ground control. Also, we will have an orbiter, which will monitor the surface of Mars for some dangerous things such as meteors or for underground water, which we can explore. And then we will have a ground event lander, which will also be monitoring the surface of Mars using the data from event orbiter and from ground control. And it will tell our rover whether there is any sandstorm on Mars, which can cause some harm to our rovers, or maybe there is some alien form of life. Actually, this is a game which I have developed to show you the possibilities of Kubernetes and Istio. And our rover is our browser. Ground control, event orbiter, and ground event orbiter. This is services from our microservice application. So player service is like a ground control. It will tell our name and will show us leaderboard, while we will be sending the score to the player service. Event service and ground service will be sending events to our rovers. Okay, so let's take a look how the game looks like. So this is my game. As you can see, I'm a little rover exploring Mars. There are some meteors falling from the sky. I can collect the alien form of life. It gives me 5 points. I can scan the underground water using space button. If I touch the sandstorm, you can see one of my lives here in the top right corner goes down. And the same if I'm hit the meteor, then one of my lives goes down. When I lose all 3 lives, the game is over. So this is simple game which I have developed. Let's try to deploy the new version because developers worked hard and they have the new version of this application. So we are deploying it. The code passes all the pipeline steps. So, okay, it has been deployed. Let's restart the game and try to play the game again to see it should be nicer because it's a new version. The new version is always better. So I'm collecting alien form of life. I'm scanning the underground water. Sometimes I'm being hit by meteors, but that's okay. So I'm continue playing the game, trying to avoid all the obstacles, sometimes successfully, sometimes not. But after some times, I'm noticing that there is no meteors, nothing. So obviously something goes wrong, and then it starts coming again. So what happens? Let's take a look at our application, at the state of our application. I can just see that my application, my service, event service, have one restart. What happens is that it crashes, and Kubernetes, it gives you out of the box. When it sees that some application crashes, it will restart it automatically. You don't have to do anything about it. It just notices that it's crashed and will restart it. So by this, you can have some sort of fault tolerance. But the problem for now is that we have only one instance of event service. And when it crashes, there is no other instances that can handle our request. So for this, we actually can scale our deployments, our instances of event service to 2. Oops. And we can see that we are having here the second instances, which will be up and running in a while. We can scale it more. Scale. We can scale it, for example, to 3 instances, or maybe to 4 instances. I believe 4 instances will be enough for us to be serving our events, even when the services are crashed. Let me restart the application. It's a bit front-end heavy, and my browser is not that fast somehow, especially when I'm sharing the screen. Okay, let's load. Okay, so it loaded, and for now we can play the game, and yeah, we can still sometimes notice some events are missing, but it won't last for long because our other instances can handle our request. So it gives us some sort of fault tolerance. Okay, let's deploy the next version of our application. So actually, some developers was again working hard to fix the problem that we had before, so the application, the service don't crash anymore. So it's being deployed. Let's play this game further. Okay, so everything looks fine. Trying to avoid obstacles, sometimes successfully, sometimes not. Okay, but after some time, again, there are no events coming. So what happens? Let's take a look. Maybe the application still crashes. I'm looking at my application and I can see that event service is running fine. So what is the problem here? The problem actually is that application may not crash. It can be unhealthy, but the process can still be up and running. And Kubernetes won't know that something is going wrong because the process is up and running. So for this purpose, what we have to do, and again, Kubernetes gives us this opportunity, we can set up some health checks. And Kubernetes should send event service. Kubernetes will send this health checks, will send this request to the service to ask if it's up and running and if it's okay. So after this, we can still play the game. There are no events because the application is still crashing. Let's continue. But if we take a look at our services, we can see that Kubernetes actually terminates the one which fails and run the new one because it can, using health checks, can notice that the service fails. Okay, so for now, let's get back to our presentation again. And let's recap what we have seen. First of all is the mechanism of self-healing of Kubernetes. By this, Kubernetes can guarantee that in case of your application, if it crashes, it will automatically heal itself. So it will run the new instance of your application. And also you can scale your application to the number of instances that you need. And actually having multiple instances is very useful, because here we will have some math. If you have one instance which is available 99% of the time, which sounds pretty good number, but actually it means that you will have a downtime of 365 days per year. Your service will be unavailable. If you just scale this application to 2 instances, it will increase your availability to 4 nines, and this will give you a downtime of only 52 minutes per year. And 3 instances will help you achieve the magic 6 nines, which is 31 seconds per year, which is very, very good result. But this is the case for manual scaling. However, Kubernetes can allow you to do auto-scaling using the mechanism called horizontal pod autoscaler, which will allow you to set up some metrics, for example, the CPU usage, to scale your application automatically. So you don't have to set up anything additionally. You don't have to monitor always your system to scale up it manually. Also, you can scale up it vertically to allow your application using more resources when it's needed. And of course, cluster autoscaler will allow you to add the new nodes to your cluster in case if you don't have enough for your application. And also, we have seen the health check. There are 3 types of health check for Kubernetes. First is liveness probe, which we have seen. This is the case when application cannot respond anymore and Kubernetes will restart it. The readiness probe is sometimes application is just overloaded and it does not respond, but you don't want to restart it because maybe it will become available in a while. So Kubernetes will just stop sending traffic to this instance, and after some time, when the application is again healthy, it will start receiving traffic. And the startup probe is for the application that starts slowly. So before your application starts, don't send any request to it. Here is the basic YAML configuration. Here is the example for readiness probe with the HTTP GET to some specific path and port and additional configuration. And the same is for liveness probe and startup probe. It's just the same configuration with just different name. But this is for the case when we know where the problem is, when we can easily understand what is the problem with application. But sometimes the problem, and usually actually, the problem is more tricky and you have to understand where is it. So for this thing, you have to set up the proper monitoring tools. And Istio allows you doing this using the proxy and IstioD component. All the proxies will send all kinds of metrics such as tracing metrics, logging, to the IstioD. Using the add-ons mechanism, you will be able to just view a lot of bunch of metrics, a lot of tracing thing and everything. Okay, so go back to Mars and see how it works. So first of all, as usual, our developers was working hard and we have to deploy the new version of application. We are deploying the new version. It's being deployed. Let's check the status. So you can see that the new version of player service is initializing. Let's try to play our game. So we are exploring Mars, but we can see that the leaderboard is disappearing from time to time. So what happened? So, oops, it blinked again. Let's play, maybe it was just a glitch, and again, disappearing. So what's actually happening? I'm not really sure. So for this, we have Istio, which will allow us to monitor our application. So we have the command istio-ctl dashboard, which allows us to view, for example, Grafana. So let's run this command. And we have Grafana with the setup. These are the default dashboards set up by Istio. I haven't done anything additional to this. Okay, so it's still loading. Let's take a look at the dashboards that we have for player service, because our player service doesn't look healthy. Okay, so request duration, and we can see that from time to time we are receiving some errors such as 503 or 500. So basically we can see that something isn't correct, but it's not all the time, because actually success rate is about 75%. So the easiest way to fix this without introducing anything to the code, because for this we will have to implement this, the developers will have to somehow fix this. Actually, we can see here it's 95% the success rate from the last period of time. We can just do some retries, and Istio allows us to do it. Okay. Istio allows us to do it just by adding some configuration, which is retry player service. This is the YAML configuration, which looks similar to the Kubernetes one. So I didn't do any changes in the code, but for now, if I'm going back to my application, I will see that there are no glitches for the leaderboard anymore. So I haven't fixed the problem yet, but I have hide it from the users. So even though there are some problem with the player service, the user won't notice it because the leaderboard is working. So in case when we receive any errors, Istio will send again the second request to fix it. Okay, let's deploy again the new version of our event service, because our developers, they are like really hardworking people. So they are, while I'm explaining it to you, they are developing the new version of application. Okay, so it's being deployed. So let's go back to our game and try to play it. So we can see that there are meteors, but there are no ground events. There is no underground water. There are no sandstorms. So it appears after some time, but okay. Apparently something is wrong for now. So we can see that the ground events are missing from time to time. Okay, what we can do, of course, we can try to monitor it using Grafana. So let's go to our Grafana dashboard. So we know that ground event is being served by ground event service. Here it is. And we can see on the request duration that sometimes our duration of the event is 20 seconds, which is like a lot. Our request takes 20 seconds to respond. Okay, but ground event, we know that it talks also to player service and to event service. So the problem could be everywhere. Let's try to see how the request uses the tracing. The distributed tracing tool called Yager, which we have here. It also provides automatically, and it collects all of this data. So let's find out for the ground event service what's happening. And we can see that we have this request which took 20 seconds. Let's take a look at it. So here we can see that everything works pretty quick. For example, player service responds in milliseconds, but event service, it receives 2 requests and it responds in 10 seconds. So we can see that sometimes the event service responds pretty quick, but sometimes the delay is 10 seconds. So what we can do here, we can actually set up some timeout. So if the request takes 10 seconds, it's easier for us just to block this request and send the new one and hope it will come quicker. And again, Istio gives us this possibility. Okay, so timeout, event service. Without any changing in the code, we can just apply the configuration, and it will set up the timeout for our application. So let's try to play the game again. You can see everything works fine. Yeah, we are receiving ground events. We cannot notice any delays. Let's try to restart the game. So sometimes it goes to the timeout and we'll have to send the new additional request. But after some time, oops, this is a bug. You weren't supposed to see that. I'm not the best front-end developer. Okay, so we can see that even though we have the slow response, we can still receive the ground event. So without any changing to the code, we could achieve some sort of fault tolerance. Okay, let's go back again to our presentation. So let's recap again what we have seen. First of all, this is the resiliency feature of Istio, which allows you to set up some retries in case of failing request, and also set up timeouts for requests. So in case if it's easier and cheaper for you to send another request and don't make user wait too long, it's better to set up the timeout. Now I want to talk about the caching. So unfortunately for now, Istio doesn't have any caching mechanism built in. So you cannot directly use some caching tools, such as Hazelcast, such as Redis. But we already are using something which has a pretty powerful built-in mechanism of caching, which is called HTTP. And I want to talk about the cache control header, which allows you to set up pretty decent caching mechanism. And specifically about the options of this header, which is tail while revalidate, which allows you for your browser to consider cache in case if your result is stale, to take it still from cache and asynchronously update the cache. So this will be useful for our event service, for example, which takes too long to respond. So we could just fetch the results from cache and allow our cache to just wait for 10 seconds, for 20 seconds to update the value. User won't notice any difference. They will receive the stale result, of course, but the cache will be asynchronously updated. The second option is stale if error. This allows your browser, when sending the request to the service, if it receives the error, to serve the cached stale result. Again, this is not the actual result. This is in cache and it's stale. But sometimes it's better to show the user some stale result instead of showing them the error. So this mechanism can be set up by Istio using this configuration. But this mechanism has some problem, which is called browser support. So actually, two of these options are experimental, and stale while revalidate is supported by not by all the browser, and stale if error is not supported at all by browsers for now. But when it will become the stable feature, you can use it, and it will increase the responsiveness of your application. One more thing that Istio can allow your application is circuit breaker. This is not the same circuit breaker as, for example, in the Spring Cloud. So you may be familiar with the Spring Cloud circuit breaker. But Istio circuit breaker, it allows to limit the number of the requests to your service. So for example, when you know that your service can handle 10,000 requests per second, when receiving 20,000 requests per second, it will just fail. And everyone will receive the error, including the 10,000 requests that your service might have handled. With the Istio circuit breaker, you can set up the limit for your service. So if you know that you can handle 10,000 requests per second, you can set up this as a limit. You can set up the requests that will be waiting for any available slot, and all the other requests will be just returned by errors. So by this, some of your users will be still serving with errors, but at least you can serve the users that you know that your service can handle, 10,000 requests per second in this case. One more mechanism could be rate limiting. This is pretty similar to circuit breaker, but it's not the global configuration, but rather the configuration per user. So for example, you can set up the limit for one user to send not more than 100 requests per second, and all the other requests will be returned by error. And also you can set up some premium rate limiting. If you have some users with the premium account, you can set up the higher limit for them. This is pretty useful when you are providing some public API to be safe from some DDoS or something. Okay, now that we have all of this mechanism of fault tolerance provided by Kubernetes and Istio, how can we know that our application is really resilient, that it's fault tolerant? And the answer to this is chaos engineering. I think some of you might hear of this term, and specifically of the chaos monkey, which was developed by Netflix. Netflix are the pioneers of the chaos engineering. And they developed this tool, Chaos Monkey, which just go to production and kill the instances of their service. Now they have the whole army called Simian army of that tries to kill the application. And by doing this, Netflix can be sure that developers, when they are developing the application, they know that it should be resilient because the problems will happen, and that they can test this this behavior. They can be sure that this behavior is guaranteed to be fault tolerant. I don't suggest you to get this Simian army and put it against your application, because I believe it won't survive if you weren't doing any chaos engineering before. And I suggest you to go with the small step. And the small steps are the fault injection provided by the Istio. So by that, you can just apply some fault to your application without doing any specific changes to the code. And you can test your application, how it will behave in case of any errors, how it will behave in case of slow latency and something like this. So you can inject some errors or timeout into your application. Let's go back to our application again. And for now, since the best chaos engineering is the one that you are doing in production, here is the, just a minute, let me clean up all the score that I have produced. So here is the game where it lives. You can scan this QR code or just type into your browser Explorer Istio demo XYZ and play this game. And meanwhile, I will try to break it. And I suggest you doing it by your phone, first of all, because I was trying hard to make this game available for phone. I was drawing some buttons from the phone. So please use your phone. And more important is because you can play the game and still watch the talk. And also, I encourage you to play this game because whoever will have the highest score will receive this nice gift from Logica, company which I'm working for. This is Amazon Echo Dot. So if you have scanned the code, then great. If not, then I will put it into the chat. So you can just go to this link and play the game. Okay. So here is our game. It's here available. Let me try to introduce some errors meanwhile. Let me introduce fault injection like abort for player service. So this will have the same bug as we had before with the blinking leaderboard. So we can see it's blinking without introducing any new version. So we still have this these failures. Let me also try to introduce a new one. -f. Fault injection delay for event service. So again, we can see the leaderboard is blinking because the error was still there. And sometimes we are stopped receiving any, so we can see that the meteors aren't coming, the underground water. So something obviously goes wrong. But I haven't changed the application itself. So it was just the application, the same application, which was stable. But I can still test that it's working fine. Okay, so for now we have this application. It's pretty fault tolerant, thanks to Kubernetes, thanks to Istio. Let's move forward and let's see who's got the best score. Have one life left. We start the game. Okay, so it's loading. So the player service doesn't want to respond to me at all somehow. Let me clean up everything. Now it will be working. Okay, so here is our best score. I believe the first one, this Hestia from Rocket Lab, was me. In case if it's not me, then please ping me. But if it was me, then, well, we have the new best score, which is Demeter Bigelow Aerospace. Please check whoever is Demeter Bigelow Aerospace and contact me using Twitter or using any other application, maybe Pine Tool, which we are using for the conference. And I will send you this nice gift from Logica. Okay, so now that we have this application, we can finally deploy the version number 2 of our event service. The story behind this version is that I have actually talked with scientists, which told me that the behavior of the meteors isn't correct. And I have adjusted accordingly. So let's try to play this game again. I have deployed it using rolling updates provided by Kubernetes. So we are playing it. The new version is being deployed. Oh, now I'm receiving the real meteors behavior, which are actually the fast meteors. So everyone is happy. I hope so. But actually, of course, this game is not playable anymore. And the good news is that I have used the rolling updates, Kubernetes rolling updates, which allows me to have zero downtime for deploying. But the bad news is that every user have received this second version. So actually, I can revert it easily back using this kubectl undo. Okay, why isn't it working? So I can actually revert it back. But the bad news is that every user have noticed this behavior, this bad behavior, and everyone is angry at me. So the easiest and most safest way will be using Canary releases. In this case, I can still deploy my new version of application, version number 2, but instead of serving it to all the users, I can send it to one small amount of users, for example, 1% of users, while 99% of users will be receiving the stable tested version. So in this case, I will still have the feedback from the user from production, but 99% of the users will not experiencing anything bad. So let's try to do it. kubectl apply. I will deploy the new version of my application, which is actually 2. And also I will deploy this Canary service, and I will deploy it only for specific. For example, since I'm the user which is from NASA, let's deploy it for the NASA users. So it's being deployed. So okay, so now I'm not NASA actually anymore because I will receive the new name of the rover. Let me restart the application again. Okay, so we don't have much time, but this is the last thing that I want to show you. would be great if the application could load faster, but looks like because of the internet it doesn't. Oops. Okay, so yeah. Okay, so let me set up for some other users. For now, you can see that I'm Demeter for Virgin Galactic. And if I set up it for this user from Virgin Galactic, let me apply this Canary release. Now I will start receiving, did I type it correctly? No, I didn't. Okay. So now you can see that this user starts receiving the new version of application. So in this case, I'm testing it on Virgin Galactic rovers. So they will be my Canary users, which will be testing my new version. When I'm from Space Dev, everything is fine, and I'm experiencing the healthy application. Okay, so what's next? We have seen that Kubernetes and Istio provides us a lot of tools for fault-tolerant application, but is it enough? Does it mean that we cannot care about implementing the fault application in our code? And the answer is, of course not, because this is only one level of fault tolerance, but there are still a lot of things that can go wrong. For seeing how can this be implemented and what can actually go wrong, I suggest you check this talk, which was actually inspiration from my talk by Mikita Prochenko and Alex Borisov. They show how to build fault-tolerant system using gRPC and REST. And also this great book, this is pretty old book, but this is one of those basic books which doesn't focus on technology, but rather on some basic things. Patterns for fault-tolerant by Robert Hammer. Here you can find the source code of my demo. You can download it, you can try to run it, you can try to play with it. And that's it from my side. Here you can see my Twitter. You can contact me if you have any question forward. But for now, if there are any questions, I will be glad to answer it. Okay, so I can see that there is a winner of this nice smart speaker. Congratulations. I will contact you.
Yeah, Sergei, I have a question.
Yeah, sure.
Two questions. First one is mostly a joke. How do I jump over the two tornadoes?
Oh, that's, you have to lose one life.
Yeah,
sorry, but
okay.
I didn't manage it also to do it. So,
okay, and the second question, probably I missed it in your talk, or I was probably just not looking. How does this work? Is it some kind of a library that I should wrap my HTTP calls, or it works like a sidecar container in Kubernetes?
It's the sidecar container in the Kubernetes. So I tried to stay to abstract from the implementation of the Istio, but I can explain it. So it runs the specific proxy, which is Envoy proxy, alongside each instance of the application. Envoy proxy, it's the same proxy, for example, as Nginx. Maybe someone is familiar with Nginx. And each call goes through this proxy. So when you call some service, the call goes through the proxy, and this proxy can handle all the HTTP requests. And in case of error, it can do some retries, it can set up some timeouts. So your application doesn't know nothing about this proxy, so you don't have to inject any library. It's handled on the upper level. And the great thing is that you don't have to, your code shouldn't be aware of Istio, of Kubernetes. So it's abstracted out.
Oh, that's nice. One more question, please. Is it possible to unite this Istio stuff with service discovery tools? For example, if we are already using Spring and Eureka and all that Spring Cloud stack, and we want to integrate or probably try Istio in some of them, can we just get the list of available services from Eureka? And
so, do you mean without Kubernetes? Or
no, in Kubernetes, but we already have Eureka with a lot of services.
Yeah. So if it's inside Kubernetes, actually Istio, they at least previously they were providing it like a non-Kubernetes specific, but from my perspective, it was really hard to implement it outside of Kubernetes. But since you have Kubernetes, it doesn't matter which service discovery you're using, whether it's implemented in Kubernetes like kubedns or any other specific. So it doesn't actually care because it interferes on the IP tables of the Kubernetes. So if you are using Eureka, it will still work fine. So you can just deploy Istio there and try to play it.
Yeah, nice. Thank you for the questions and for the answers, and
yeah, thank
for
you.
a great talk. Yeah,
thank you.
Thank you for your talk. It was very insightful.
Thank you. Okay, so if there are no any other questions, at least I cannot see it, then thanks everyone. You can always contact me on Twitter again. Maybe you have any questions after that. So have a nice conference and a nice day.
Thanks.
Yeah, you too.
You too.
Have a good day.
Yeah.
Bye.
Bye.